Hello everyone. So, as you know, my name is Adil Imam, and you are obviously staying at home doing several household works, household chores, and of course, you're spending time on your mobile phones, in YouTube, Instagram, WhatsApp, various social media, and sharing things, posting things. So, but above all, things are getting bored, and same things are being repeated, and there's no interest in doing something extravagant or very unique in this quarantine phase. But for the sake of mankind, we got to do it. So I'm not gonna force my vendetta over it, or I'm not gonna put forward my agenda towards it. It's not part of what I am trying to say here. Actually, my YouTube channel has been longly paused. I mean, I was not no more interested in it, to be honest. But today somehow I got the inspiration, and the inspiration came through my most closest friend Munisa Nigar. She is not a YouTuber, so you can't find her on YouTube. She lives nearby, and she just started an Instagram video today. So seeing her, and I got inspired seeing her, and thought, why not try something new? Why not try something new? Means, why not go out of the box, think out of the box, which always tells me that I can go out of the box and do something different. So the main thing that I am focusing on today are simple basic questions that arise in the minds of people. Simple basic questions, as in, I mean, why do people fall while sleeping on a banana peel? Not these kind of questions, but simple questions which everyone has in their mind, but they somehow try to say that, okay, this is the question, maybe this is the answer, this will be the answer, we know this, we know that, but no one exactly knows the correct answer, or no one, most of them does not try to do. So what I'm gonna do is just figure out the one question. I've got one question in mind, and I've written it down on the copy, and so as you can see, I've written down the question on the copy, and this is just one basic simple question that can arise in minds of students in high school, maybe first or second year in college. So what is the question? Let's see. do sorry do eyes have zero energy, that means null energy, zero, totally zero, at absolute zero temperature? Absolute zero temperature in the sense 0 Kelvin or minus 273.15 degrees Celsius. Now this is a simple basic yes no question. So I want you guys to pause the video for the time you want to think over it. Think over the question very, I mean, focus on the question more, and don't try to get tricky, but apply your knowledge, apply whatever you know, and just try to answer the question, because it's simple yes or no. And pause the video. I will obviously tell it after now, but you can pause the video and think of the answer, and then watch the video again. So I'm gonna tell it in a count of 5. So a lot of you have thought of the answer. I mean, most of you have, those who are thinking by applying their knowledge, by applying what they've learned from books, from high school books, college books. So they think it's obviously yes, that eyes do have zero energy, because the simple explanation to this question is that when ice freezes at 0 degrees Celsius, but when it is taken to 0 Kelvin, it gets rigid, it gets solid. So all the particles in ice get rigid and get contracted in a particular lattice. So how can they move? How can they have any kinds of energy? I mean, in terms of vibrational energy or kinetic energy. So they cannot do. The gas molecules present inside cannot move, they are rigidly held. Yes, it's a valid explanation, and I give you credit to it, but I just happen to give you a half marks for it and not the full 1 marks, because the real answer to it is no. Now those of you who have thought of, no, they might be going, hey, hooray, let's do it, we did it. But I can say many of them don't know the real explanation. But I'm not here to criticize anyone, so let's not talk about that. So there are actually what happens at 0 Kelvin. Ice, as we know, is nothing but a cube. It's just a three-dimensional figure. It's a cube, though it's not proper cube because I'm not good at drawing. So ice is a cube and it has particles all over it. It has a crystal lattice shape and particles to it. So the energies associated with ice, first is vibrational energy. Now, vibrational energy is the most common energy because the gas particles collide with one another. They vibrate. When temperature is applied, they vibrate. They collide with the walls of the crystal lattice, and they produce energy through that. So this energy is obviously responsible to contribute in their masses or their energy. Now, what happens when we take back this ice from the given temperature to absolute zero temperature? Now here comes a certain question, what happens then? So the thing is, when at 0 Kelvin the ice particles get rigid, the crystal lattice becomes rigid and the particles are held very tightly and strong in their position, so no interstices or defects are produced at 0 Kelvin, and they are held very rigid and tight so that they cannot move even. Now if they cannot move, there cannot be any collisions, or there cannot be any collisions with the wall or collision with the atoms itself, or the atoms cannot move to produce kinetic energy or any other forms of energy. Even potential energy is not present, so, and work is also not done, so there is no term called energy. So the obvious answer should have been yes. Then why am I goddamn saying it no? Why is the ice still having energy at absolute zero temperature? This is because of a reason. Now the reason to it is there is another term related to this energy, and that is quantum fluctuations. Quantum fluctuations. This is quantum, you have definitely heard in high school in class 12. Of course you have first heard it, that there's something called quantum mechanics, atoms, Bohr's model, J.J. Thomson, Rutherford split experiment, alpha decay, beta decay, radioactivity and stuff, fluctuations, ups and downs, go back and forth of some things. So what is quantum fluctuations actually? What is quantum fluctuations? Quantum fluctuations generally are present in every single matter in the universe, known universe. Now question comes, if I'm not going into details of what quantum fluctuations is, because maybe I may do it in some other videos, but quantum fluctuations cannot be got ridden off. So at 0 Kelvin, that means at absolute zero temperature, ice have energy, and that energy combines only quantum fluctuation. So at 0 Kelvin we can restrict vibrational energy, of course make it zero, totally equal to zero, but quantum fluctuations can never be zero. Now question is why can't quantum fluctuations be zero at all at absolute zero temperature? So as we know from quantum mechanics, there is a scientist named Heisenberg. He has given a Heisenberg's uncertainty principle, which says del x dot del p greater than equal to h by 4 pi, where h is the Planck's constant, del x is the uncertainty in position, and del p is the uncertainty in momentum. Now why is quantum fluctuation present? So at absolute zero temperature, we get back to our previous discussion, that particles are tightly held in their crystal lattices, and no interstices are there, but still the gas particles try to a little bit move or try to shake, but still they are held very close to one another. Now there is uncertainty in position. As we know from Heisenberg's uncertainty principle, we cannot measure the position and momentum accurately at the same point of time. So if we cannot measure the if there is del x amount of uncertainty in the position of a particular atom present in the crystal lattice at absolute zero temperature, then there must be a momentum uncertainty to satisfy this relation. Now, since all particles are rigidly tightly held and rigidly placed in the crystal lattice, so that uncertainty position is very small. That means del x is small. So del p, that is change in uncertainty in momentum, should be very big, big enough to match this certain equation, that is the Heisenberg uncertainty principle equation. So due to this, we know del p or simple p momentum is given by m into v. What is this v? V is velocity. Now we know kinetic energy is half mv square, or better, we know k is equal to p square by 2m. So by this relation we get, if there is momentum in a body, then there is definitely a kinetic energy attached to the body. So since quantum fluctuations say that there is uncertainty in momentum, that means there is momentum present in the ice even at absolute zero temperature, then since momentum is directly proportional to root over of kinetic energy, then of course there has to be a kinetic energy present in the crystal lattice. So if kinetic energy is present, then there must be a presence of energy. And since you can see k is equal to p square by 2m, p square means if you whole square a negative term or a positive term, you get positive, and mass can never be negative except for tachyon, which is totally a different concept, which I can discuss it later in other videos. So m is, for now m is positive, let's consider it positive. So if this total term is positive, that means kinetic energy is positive. So kinetic energy is positive, there is no vibrational energy. Due to quantum fluctuations, we get a kinetic energy which is positive, which adds to the energy. So we can conclude that ice at the absolute zero temperature does not have zero energy. It has energy due to this term, quantum fluctuations. Quantum fluctuations, why? Because they arise due to Heisenberg uncertainty principle. Now that's sort of an explanation. If that helps, it's good. And so if you like the explanation or the video, you can like it and subscribe to my channel. You can also comment on my mistakes or on what things I should more focus on from the next video on, so that it can help me. And goodbye for now.